Hi, and thanks for watching. In this video, we're going to look at how we can use Python to get the time in milliseconds. And just to clarify, what we mean by a millisecond is basically this one here. So it's 1,000th of a second. Now you might be wondering why we'd need to get the time in milliseconds, and the most obvious answer to me is when we want to benchmark our code. So we want to see how fast something runs or how quickly we get a return from somewhere. That's just one of the reasons. It could also be just pure curiosity. It could be you want to know what the time is in a really very accurate level of detail. But whatever the reason is, what this video is going to concentrate on is how we get the time in milliseconds, not what we do once we actually have it. We're going to look at three different methods. The first method is milliseconds and fixed time. The second method is milliseconds and relative time. And then the third and final method is milliseconds and time of day. So let's start with fixed time. And what I mean by this is we're going to be measuring how much time has passed, how much time has elapsed since a fixed point in time. Now for Python and for computing in general, the starting point for time is called the epoch. And this is the point where Python considers time to have started. And so the passage of time is always going to be measured against the epoch, or that point in time. So the epoch can actually vary depending on the operating system being used. For Unix and Windows machines, it's midnight on January the 1st, 1970 UTC time. Now UTC is a French acronym. It's a standard of time. It's called the Coordinated Universal Time, and it's basically GMT, Greenwich Mean Time, but without daylight savings adjustments. If you want to find out what your machine is, what the epoch for your machine is, there's a very easy way of doing that. We import time, and then we use gm time, and we're going to pass 0 parameter. So I'm using a Windows machine, so it's no surprise to me that I've got 1970, the 1st of the 1st, and midnight. Okay, so that's the epoch, and that's our fixed point in time. So now we have this fixed starting point. How are we going to measure time that's passed? Well, luckily for us, Python has some functions for this in the time library. So time is a Python standard library. We don't need to download it, but we still need to import it, and we can get very easily the time in seconds that have passed since the epoch. In all of these examples, I'm going to import time, just as a matter of course. And if I do time.time, this gives me the time in seconds. But what we actually want is the time in milliseconds. So as you can already see, this is quite a big number. I think this is about 1.6 billion seconds. So I want the time in milliseconds, which is thousandths of a second. And how do I get that? Well, I get that by multiplying this by 1000. The other thing to bear in mind is that this function actually returns a floating point number. So I might want to make it a bit cleaner, but just by rounding it and converting it to an integer. So how do I do that? I'm just going to run the functions again. So sorry, I'm going to make it an integer, and I want to round it first of all. Time.time, and we want to multiply by 1000 because we're going to go from seconds to milliseconds. There you go. So that number there, this very large number there, that's how many milliseconds have passed since the epoch. So that's obviously a very good basic way of getting our time in milliseconds, but unfortunately it does lack precision. And let's face it, if you're looking for the time in milliseconds, the one thing you probably want is precision. So why does it lack this precision? Well, basically because this function, as I said in the beginning, asks for the time in seconds. So it can't guarantee, because it's asking for the time in seconds, it can't guarantee that whatever the system returns is anything more accurate than the time in seconds. But we want the time in milliseconds. So this can only guarantee the time in seconds. So it does lack a precision that we probably are after. So realizing that there needs to be this level of accuracy, Python from version 3.7 upwards has another function, which is also in the time library, that measures the time, time that's passed since the epoch, but this time rather than seconds, it measures them in nanoseconds. So a nanosecond is 1,000 millionth of a second. I can barely say it. 1,000 millionth of a second. I've written this down here just to let this sink in what we're talking about. 1,000 millionth of a second, which is basically a billionth of a second. So this this new method from version 3.7 onward obviously has the accuracy that we're looking for, and also the other advantage is it actually returns an integer value, so we don't have to worry about any conversion. So again, it's in the time library, and it's pretty much the same as the other function, apart from this time it will actually return us something in nanoseconds. And if I just run that, so that is basically the time in nanoseconds, billionths of seconds, and we want milliseconds. So how do we do that? Well, we need to, rather than multiply in the previous version, this time we have too much precision, so we actually want to divide this by 1,000,000. So to get from nanoseconds to milliseconds, we're going to divide by 1,000,000. And how do we do that? Oops, sorry, we do that easily. So I'm going to import time again. This is in nanoseconds, and I'm going to divide it by 1,000,000. Just so I can see what I'm doing on my screen, I'm just going to put these little underscores just to break it up. So there you go. That's how many milliseconds have passed since the epoch, and you can see there's obviously a difference from that function we ran before. Not a big difference, but there is a slight difference because obviously more time has passed. So these are the way that we can get milliseconds using fixed time. This is method 1. Now we're going to look at method 2, which is milliseconds and relative time. Now before I do anything, I'm just going to clean the screen because I think we're probably a bit too far down. So I'm just going to restart my output. I'm just going to get rid of these, and then we can look at our method 2. Okay, there we go. So method 2. So this is milliseconds and relative time. So whereas before our previous method, method 1, we were measuring time that had passed since a fixed point, since this epoch. With method 2, all these examples, they really have no defined relationship with any kind of real world time or with the epoch. So this means that the value that they're returning isn't defined against any starting point. So by itself, it's not really that useful because I don't know what it's relative to. But we can use these methods to actually measure time intervals. So we could call the method, we could call the time, run a piece of code, call the time again, and work out what the difference is between those two times, and that could be useful. So these are really for measuring speed, and again, these are from the Time Python standard library, and we're going to look at 2 of these in particular because they both measure time in nanoseconds, which are these 1,000 millionths of a second, so they have this level of precision that we require. The first one we're going to look at is monotonic time, and this will give us a value of a monotonic clock. A monotonic clock is basically a clock that can't go backwards, and it's not going to be affected by any system updates. The thing again about this method, and I just want to reiterate this, is that the return value isn't defined by any kind of real world relationship. So let's just run this function, and you can see what I mean. So I'm going to import, again, I'm importing the time library, and I'm going to run time dot monotonic. And I want the nanosecond. So if I just run this function, I get this number returned. Now the thing is, again, I don't know what this number relates to, but what I can do is I can actually use this 2 calls in some code, squeeze a function in between, and actually work out how many milliseconds or nanoseconds have passed, and I can use it that way. I think it's going to be easier to use this in an example. Okay, so let's run some code just to illustrate our point. I'm going to start off by importing time, and I'm going to give a start time, which is time in nanoseconds, and I'm just going to print this out. Doesn't mean anything on its own, as I say, but it could be useful for us just to see what the start time is, how it prints. I'm then going to run a little loop. So, well, x is, let's do less than or equal to 100. We're going to print x, and then we're just going to add 1 onto it. So we're going to print up to 100. We're going to print up to 100, and then I want to see what the finish time is. And again, we're going to do the and I'm going to print finish. Oops. sorry, and then we're going to work out what the duration is of that. So the duration is the finish minus the start, how long it took us to run this code, and we could just do a little print statement as well. So that took how long did it take us? Now again, so we got nanoseconds, we're getting nanoseconds, we're going to get to milliseconds, so I'm going to have to divide this by 1,000,000. Divided by 1,000,000, and that's in milliseconds. So now hopefully if I run this code, oh, there you go. Let me come down here. Not sure how easily you can see this. Okay, so what I've got here, I've got printed out the start of the monotonic clock over here. I'm printing out my numbers, and we've gone all the way to, let me just bring this up the screen a bit, make sure you can see it. We've gone all the way to 100, and I've printed out the finish of the monotonic clock, and then I've got that took 16 milliseconds divided by the nanoseconds by 1,000,000 to get the milliseconds. So that's how we can use it with a monotonic clock. So now let's look at another function that comes under our relative time method, method 2, and this is really similar to the monotonic clock, but this is actually called a performance counter. And this is a counter that doesn't include any sleep time, and it is system wide. But again, as with the monotonic clock, what this is going to do, it's going to return us an undefined value. So let's have a look at the function. Let's just start. Let me just clean this out. Sorry, 1 second. Okay, let me just make some room over here. Let me just clean this out. So this is the time performance counter method, and again, so let's just import time, and I'm just going to print it out so we can just see what it returns without any and again, this is nanoseconds, so if I just print that out, this is return this random number over here. Doesn't mean anything on its own again, because I don't know what it relates to. See the monotonic, again, just random numbers, there's no relation, so on its own it's useless. But as we did over here, I can actually do the same thing. So I can run this, sandwich it in between 2 bits of code to see how long it takes something to run. So what I'm just going to do is I'm just going to copy my code here. Let me bring this up. Oops. Bring it up so you can see it. So instead of time monotonic, we're doing the performance counter. And we want to print out the start time, we're going to print out the finish time, and we're going to run the same for loop just to see how long it takes for it to run. And again, the code is pretty much the same because we're getting a nanosecond, so we want to divide by 1,000,000 to get milliseconds. And I'm going to print out the start and the finish time and run the same loop in between, and we just want to see how long it takes. So there you go. So it's printed out the counter to start with, and you can see this is hugely different from where we printed before. So I don't know what it's relative to, but it doesn't really matter in this example because all we're doing is saying, okay, print the start time, run the function, and hopefully you can see it there. Bring this up. We've got that end time of the clock, and that took 5 milliseconds. So that's the performance counter, and that's the monotonic clock. So both of these methods are really useful for measuring time intervals. So that's method 2, which is relative time, and the final method we're going to look at now is looking at milliseconds and time of day. Now, as the name suggests, we're going to look at how we can get the time of day in milliseconds, and for this, rather than the Python standard library time, we're going to be using another Python standard library, which is datetime. Now, before we do anything, let me once again just get rid of all my code. So just give me 1 second. Okay, here we go. So let me just clear my kernel again. And let me just get rid of all the text. I'm going to keep this up just because it it could be useful, but let me just keep that up. Okay, so this is from the datetime standard Python standard library, and the first function we're going to look at is datetime now. Now we can just call this function on its own just to show you what we're looking at. So I'm going to import datetime, and I'm just going to run datetime now. Okay, so what this returns the value with some key attributes, and let's have a look at those. So this function is just basically return the current date and time in my location with the following attributes. So I've got the year 2021, I've got the month 2, which is Feb, I've got the day 19th, I've got the hour 16th, 4 o'clock, 4 p.m, minutes 4:01, seconds 30 seconds, and these are milliseconds. So not milliseconds, sorry. These are microseconds. These are millionths of a second. So as a default, this datetime module returns the time with microseconds. Now, the thing to bear in mind, this is all relative. So these microseconds are relative to the seconds, which are in turn relative to the minutes, in turn relative to the minutes, the hours, etc. So it's all relative. It's essentially a clock. So the microseconds that it's returning here are relative to the seconds. But what we actually want is we want the time in milliseconds. So to get the time in milliseconds, we have to divide by 1,000. We also might want to just tidy this up a bit. So let's have a look at how we do that. So I'm just going to import the datetime module again, and this time I'm just going to and I'm going to print it so that it will be nicely formatted, and I'm just going to show what we want. So we have the datetime, we have microseconds, which is the default attribute, but what we actually want is milliseconds. So I'm going to divide that by 1,000, and if I run that, there you go. So it's a bit better formatting over here. So 2021, February the 19th, it's now 4:04 and 52 seconds, and that's how many microseconds there are. But I want milliseconds, so divide it by 1,000. So that's the current millisecond time. So that's using the datetime now module. We can also use another module within datetime. Works pretty much the same, but it works on the UTC, or the coordinated universal time we looked at before. So it gets around any issue with local time, time zones, etc., and it works off a time standard, which is UTC, which is very similar to GMT. So let's have a look at that one. Thing to bear in mind with this is I live in London, so my clock is on GMT time anyway, so there won't be any difference in the actual output, but I think it's just still worth looking at how it works. So if I call the function, let's see what it looks like. Just do a basic, so datetime. So this is that coordinated universal time. So if I just call that, we can see what the attributes are. So again, it's very similar to what we saw before. It's 2021, February 19th, 4:06 now. That's how many seconds? 49 seconds. And this is in the microseconds, so 605,806 microseconds, which again is relative to the seconds, which are relative to the minutes, which are relative to the hour. The only difference is that this is the UTC time, which we talked about, rather than the local time. In this example, it doesn't make any difference because they're the same, because I'm in London. But if I was somewhere else, there would be a difference. So we could, because we have the microseconds, we want milliseconds, we could use the same format over here, and it would do exactly the same thing. But because there's no difference time, let's just look at a slightly different way of getting to it. And for this one, we're going to look at how we can convert this datetime object into a string to make it a bit easier on the eye. And so to do that, we're going to import datetime, and okay, so Okay, and I'm going to now convert this to a string, and I can format the string as well. So we want to do year, month, sorry, that's a bit lowercase. Let me just move this. Year, month, day, and then I'm going to do hour, minute, second, and microsecond. So hopefully if I print this out, sorry, invalid format string, what have I done wrong there? So apologies, I haven't formatted my string correctly over here, so let me just do this properly. So that should be capital, year, month, day, and then hour, minute, second. And if I run that, there you go. So I have a nicely formatted string, which is 2021 February 19th 4:10:43, and this is the time in microseconds, but again this microseconds really relates only purely to the second value here. So now I want to get this value in milliseconds, so I want to divide by 1,000. I can't divide by 1,000 because this is a string. So what I can do is I can slice. Let me just put this here. So what I can do is I can effectively get rid of these last 3 digits, and that will be the same pretty much as dividing by 1,000. Maybe what I can do as well, I can just put this in a print statement so that it's a bit nicer in the formatting. So I'm getting rid of these last 3 digits over here. So I can get the time in milliseconds rather than microseconds. If I run that, there we go. So that is the time, current time in microseconds. So we've looked at these 3 different methods of getting time in milliseconds using Python, and I think on the method 1 we saw the upgrade from Python 3.7 onwards, where we had the nanosecond time, and we can really see that as a huge advantage because it gives us that precision that we need. For the other methods, it's really difficult to comment on what the best practice is or what the best way of doing things is, because they all provide time in milliseconds as the answer, but I'm not really sure what the question we're asking is. So the answer is correct, but whether it's correct for the question really depends on what the question is, if that makes some sense. So the key for me is that you need to find the right method that fits in with your requirements. So looking at factors like what is the actual level of precision that's required? Does geographical location make a difference? Should you be using the UTC? Is that relevant, or do you not need it? And how complex do you want it to be? And all of these will really determine the right approach to getting your millisecond value. But luckily we've seen a few different ways of doing it, and they all provide the correct answer. So a lot of this, as with a lot of the Python work, really comes down to your personal preference and what you think makes the most sense for what you're trying to achieve. I hope you've enjoyed this video. Thank you for taking the time, and thank you.